In this section we'll look at solving problems involving Pythagoras within 3D shapes. Most of these problems will be within a cube or a cuboid, and what we're generally going to be looking at is we're going to be looking at something called the space diagonal. So space diagonal for a cuboid, for instance, is one which goes from the, say for instance, the bottom front left to the top back right. In order to do this, we need to look at using Pythagoras twice. So we need to basically identify two right-angled triangles we can use. If we were to look directly down on this cuboid from above and looked at the base of it, what we'd basically see is a rectangle. And what we can do with a rectangle is we can split it into two right-angled triangles. Remember, this rectangle here at the bottom is representative of the base of our cuboid here. So we can add a line from here to here to represent this line, giving us a right-angled triangle going round here with the right angle in this corner here. What we then have is another right-angled triangle created here. So from B, and we'll call this corner here C, so from B to C is a horizontal line, and we know C to A up here, straight up and down, is vertical, so they are perpendicular to each other, in other words at right angles to each other, so we can put a right angle in this corner here, and this gives us a second right angled triangle which we can use for our second law of Pythagoras, and this should be able to then give us the length from A to B. In this example we've been asked to find the space diagonal BH, so this line here that runs from B through the middle of the cuboid to H, and again we have our two triangles which have already been drawn in for us. So our right angled triangle down on the base of the cuboid and our second right angled triangle here. So what we'll do is we'll start off with the triangle BCG and we'll redraw over here and add on the dimensions. So 12 centimetres on this side and 4 centimetres here. We can call the third side then X, and then we'll use a bit of Pythagoras. So we're looking for the hypotenuse in this case. So x squared equals 12 squared plus 4 squared. X equals the square root of all of that, which comes to 12.65 centimetres. What that then gives us is we can take this information, this 12.65, and we can now write it on this side here, this side BG. So 12.65 in that space there. Now that we have this 12.65, we can use that information on the second triangle BHG, this triangle here, with the right angle down in the corner here, and we can use Pythagoras to find the length of BH. We're going to take this triangle and we're going to draw it down here. And we can now put our dimensions on. So 12.65 from the previous part of the question for the line BG, and 7 centimetres for the height of the cuboid GH. And we'll stick a Y on this side because we've already used X. Again, we're looking for the hypotenuse here, so hypotenuse y squared equals 12.65 squared plus 7 squared. Y equals the square root of all of that. And again, into your calculator for the answer, which is 14.46 centimetres, and that's the length then of BH. Therefore BH equals 14.46 centimetres.